I've removed the plastic lid from the Swarm electronics box here, which is mounted on the back of the solar panel. It's lying face down on the solar panel. And we've pulled this plug out of the cable gland, it's called, that was plugging up a extra pass-through into the electronics box. Previously, all that was going into it was the connection here to the solar panel. But pushed this cable in through there, the 4-conductor cable, ground, 3.3 volts, data and clock for the connection to the moisture probe, and the jack going into the I2C connector here has 4 wires that will need to be soldered to these these 4 wires from the cable, and then on the other end of it here we will solder the actual probe itself, and then weatherproof all of that. So making progress here in the weatherproofing. I also added in this this is a USB-C elbow so that I could just plug a USB-C connector in here instead of having to remove the Adafruit Feather microcontroller, which is underneath this little screen. It's a stack here with the screen plugged into these, which are connected to the pins of the Feather, which is underneath it. Over here is the Swarm satellite modem. Excuse me, the Model 1 M138 modem, and you can see it has 2 cables coming out of it up here. There's the cable that goes to the antenna for the transmitting and receiving from the satellite, the Swarm satellites, and then there's another black cable here that is the GPS antenna. This little tile has a modem for communicating with the satellite. It has a transmitter for about a 1-watt transmitter for transmitting to the Swarm satellites. It has a satellite receiver, and it has a GPS receiver all packed into this thing, which is called a tile, and which connects here. And that's where we're at right now with the weatherproofing process. And now we've done our soldering and heat shrink tubing to connect the cable, probe cable coming in through the cable gland into the electronics box, and soldering that to the I2C plug that will plug into the Feather microcontroller to bring the data from the probe into the microcontroller. Just put a second coat of polyurethane weatherproofing sealant onto these 3 probes, onto the electronics especially, and the plugs there. And tomorrow we'll put a couple coats on the back. The sensing part of each of them is covered up with masking tape, so we're not coating that part of the probe. Then hook one of them up to the cable that's just been installed in the Swarm Eval Kit, and test it out. One of the weatherproofed probes is now soldered to the cable going into the satellite transceiver. Now the heat shrink tubing for the individual probe wires has been heated and shrunk. And a coating of coax putty for outdoor cable installations to cover up everything, in addition to the polyurethane spray and the heat shrink tubing and so on. Actually, I Had a larger piece of heat shrink tubing to cover where the cable putty is now, but it was too big and was clearly going to require too much heat to continue shrinking onto the probe, and would have, I think, melted all the electronics before it fully shrank. So this probe is we're gonna see how well it survives with just the cable putty, and then of course I got 2 backup probes, and we'll be getting a more suitably sized heat shrink in case I need to use those. And here we are testing it out. I can see occasional green flash of light down there. Means that it has an acceptable noise level, so that it should be able to communicate okay with the Swarm satellites. We have the newly installed cable and its probe on the end of it, stuck into some potting soil here. Just using that because the plant container here that I was using, the soil froze solid and I couldn't get a probe into it, so we'll use some potting soil. Obviously I won't be doing this sort of measurement in the dead of winter, but for now, for testing purposes, that should work okay. We just want to see that the probe is still working, and that something like a measurement shows up later tonight on the Swarm server on the Hive. I have a DOS batch file here now on my desktop for starting up the Python script that scrapes my data off of the Hive server. So we'll take a look at that and see if we've gotten anything back. I left the eval kit outside overnight, and for the first time, and oh yeah, we're getting data from it. Let's see, down here where we're on the 29th, 0129, that is when Greenwich Mean Time. That means a little after 7 o'clock on the 28th p.m. That's when I put everything outside for its first test of the weatherproofing. And sure enough, we're getting intelligible data there for the soil moisture, the blue dots, and the temperature. I'm surprised that we're getting well, of course, the temperature sensor is on the microcontroller, and so it's all sprayed with polyurethane and covered up with cable putty. So, but I guess eventually it reaches some sort of equilibrium with the air temperature, and it's at least reasonable. Here, let's see. Temperature, well, it was probably closer to 35 than to 42, but so I may have to use a little bit of subtract a calibration coefficient, but it looks like it's still going to give us some usable temperature data, and also the soil moisture readings are in line with those we were getting before. And so I'm hopeful. I would like to see some indication of, let's see, we've got some indication of drying going on here in the soil as it drops down a little bit. But I'd like to see some indication of increase in soil moisture. It's supposed to rain in the morning, and so later on this morning, I mean, and or maybe this afternoon. I'll have to check the weather report again. And hopefully we'll see some results from that. If not, we'll resort to the watering can. Well, the Swarm Eval Kit spent its first night outside last night. Expecting a little bit of rain today. Haven't gotten much. There's just a few. It's had its first few raindrops splashed on it, but I'm going to help it along a little bit with a watering can here to pour a little water directly on this supposedly weatherproofed probe down here that I've moved into this concrete planter. And we'll give it a little artificial rainfall here and see how it does. It's been a long time before there's been, since there's been much sunlight, so I don't know how much longer the batteries will stay charged enough to deliver the 3.3 volts that is required here. I don't know. Yeah, I saw a little bit of a green flash there, so that's what's supposed to happen periodically to indicate that the noise level is sufficiently low that it would be possible for the device to hear satellites and to also transmit successfully to them. We'll see. It's just a little after 1 p.m. and 1:40 p.m. Approximately, it should take its next measurement, and so we'll watch the hive to see if anything shows up from 1:40 p.m. today, and if it indicates moisture soil. Well, it was around 1 p.m. here. That's 1300. At Greenwich Mean Time is 5 hours later, so it was around 1800 that I dumped some artificial rain into the soil, potting soil being monitored by my new weatherproofed probe, or probe I hope is weatherproofed. And then the Eval Kit should have sampled that soil moisture level at about 1840, something close to that. And so now we'll check and see if any data was relayed to one of the Swarm satellites and then downloaded to the Swarm server called the Hive. We'll check and see what we get here. And oh yeah, it looks like something happened there. All right, we'll check and see if this is. Let's see, the data point would be way up here somewhere, and yeah, the time would be down here. Let's just maximize this. Get a better view of it. Data point would be way up there, corresponding to this temperature point here. And the time on that is, January 29th, 1843. Yep. So that would be a data point that's clear off the scale here, above 900. So we'll just we'll close out this, and we will open up and edit the script itself, where I had set the maximum value for the y-axis for the moisture level to be 900, and we'll go up, say, to 1200, and we'll save and then rerun the script. And yeah, okay. There's our first value up here. Well, we'll maximize again. Sorry. There's our first value at 1843, and it's gone up to about 1,000. So from around 600 where it was previously, I think. The data point previous to that one was at about 620, something like that, up to 1,000. So we're definitely the probe has been waterproofed, so it didn't stop functioning, and it is registered the artificial rainfall so that we have a new, very high, much higher moisture level. And it'll be interesting to see that drop back down over time. It's pretty slow though, because there's not a lot of evaporation. It's not real warm outside, and there's no drainage in that cup holding the potting soil, and there's no plant in it to soak up any of the moisture. So the moisture level stays static for quite a long time. But and I don't know how much longer the charge will last on the batteries in there. We did get a little bit of sunlight after the supposed rainstorms this afternoon, but not much. And we'll just see. We'll wait and see. But I'm concluding that we've had a successful weatherproofing of the probe, and so this video can end on a positive note.